So today we're going to cover section 2 of chapter 1, and today we're going to learn about measuring and constructing segments. Now again, as I told you last week, I'm not going to expect you to draw precise figures. You're not going to need to get a ruler, you're not going to need to get a protractor or a compass, but I just want you to understand that if you see something and they ask you to find the word construction on an SAT or PSAT, then that would mean when you would have to get out the tools and precisely do it. On an SAT or PSAT, the only thing you need to bring is a pencil and a calculator. Again, they're not going to expect you to draw precise figures on that type of test either. So let's go ahead and look at our first definition from this lesson. And on this slide, we're defining what a coordinate is. So we're going to be using a number line. And a coordinate is a number that corresponds to a point. So in that picture of that number line, I could state that -2 is the coordinate of A, or that +2 is the coordinate of D. So a coordinate is just the number that would correspond to a point. Now, when I am trying to find the distance between 2 points on a number line, I can find that distance by finding the absolute value of the difference of the coordinates. Now, the reason why we're going to find the absolute value is when I go to find the difference, which is a subtraction problem, the order that I choose to do the subtraction won't make a difference as long as I find the absolute value of that difference. Now, if you don't want to find the absolute value when you're done, you could always just choose to always subtract the bigger coordinate from the smaller coordinate. So you could always do big minus little, but I'm going to show you both ways here. So for example, if they ask me to find the distance or the length of segment AD, I could either choose to do A to D or D to A. So if I do the first one, A to D, I'm doing the small coordinate minus the larger. It's always a difference. And when I do it in this order, after I do that subtraction problem, I'm going to need to find the absolute value. The absolute value is always just how far away is that number from 0. So -2 minus 2 is -4. And then when I absolute value that, -4 is 4 spaces away. So the absolute value of -4 is +4. Now, even if I did it in the other order, if I did D minus A, if your teacher back in middle school taught you how to subtract integers, and that's what I'm doing here, I don't know if your teacher taught you like keep, change, flip, or stay, change, change. Whenever you subtract integers, we would keep the first one the same, change this to addition, and then flip this or change this to the opposite sign. Again, I could do absolute value of that, but again, if you do big minus small, then your answer is always going to come out positive. So either way, the order doesn't matter here. Just remember to absolute value the final answer. So whenever it's asking you to find the distance of 2 coordinates on a number line, you're just really trying to find out how long it is, or how big is that segment. Now, keep in mind that you can also just go here and you could count the little gaps. There's 1, 2, 3, 4 spaces in between A and D. So if you've got a visual and you have a number line and they ask you to find out what is the length between 2 coordinates, you can do it that way as well. But if they don't give you a number line, then just do the subtraction. Next, we're going to define what a postulate is. And a postulate is just a statement that's going to be accepted without proof. Now, this statement could be a rule, or it could be a definition. So just some kind of statement that somebody's gonna, like I'll give my classroom rules, you just have to accept what I'm saying without proof. So a rule or a definition would be a good way to describe what a postulate is. Now, we're also coming up, and not right now in this lesson, we're also going to be learning theorems. And that's going to be a rule that can be proven. But for now, we're just going to talk about postulates. Now, I don't want you to memorize that the ruler postulate is postulate number 1, because every textbook is going to give a different number to some of these postulates. The way that our textbook does this is the order that you learn something, that's the number it gives to the postulate. So for example, the ruler postulate, our book is calling it postulate number 1 because that's the very first postulate we have learned in this textbook. If another textbook, maybe that a different publisher makes, maybe the ruler postulate is postulate number 2. So in their book, they might say, well, in our book, we're going to say the ruler postulate is postulate number 2. So whenever we learn any of these theorems or postulates, you don't need to memorize that postulate 1 is the ruler postulate, and it states that the points on a line can be matched 1-to-1 with the real numbers. All I want you to know is that the name is the ruler postulate, and this is what it means. Now, once you have a coordinate system, and in this case it'll be a number line, the distance again between any 2 points equals the absolute value of the difference of their coordinates. So this is the exact same thing that was on the previous slide. So we're going to subtract the 2 coordinates and then find the absolute value of that difference. So again, let me show you another example. Let me go ahead and set up my number line and show that points could be matched 1-to-1 with the real numbers. So I'll make a number line here. I'm going to add the numbers, -1, 0, 1, 2, 3. And now I'm going to match those with some letters. So once you've established your number line, and it's always set up the same way, you have the negative numbers on the left, 0 in the middle, and then positives on the right. And again, they may have it balanced or anything that's labeled like this. So let's say I ask you to find the distance from E to A. Now, if you've got the visual, you can just count the spaces, and I can see that from E to A, it's going to have 1, 2, 3, 4 spaces. So I can do it that way if I've got a number line. Or I'm going to also show you to find the difference and then find the absolute value. So again, remember the order is not going to matter here. I can either do from E to A like it was asked, or A to E. So if I go from E to A, I'm going to again find the difference. So E is 3, A is -1, and remember we're finding the difference, so a subtraction problem, of these 2 numbers. And again, I'm going to absolute value it, flip this. Find the absolute value of 3 plus 1. 3 plus 1 is 4. And the distance would be 4. Same answer I got when I just counted the little spaces. I could do it the other way as well. -1 minus 3. Absolute value it. And again, I get the same answer either way. So if you tend to do the bigger number minus the smaller number, remember, don't worry about absolute valuing it. You're always going to get a positive result. And then the same thing if you just counted the little gaps or the spaces. So the distance from E to A would be 4 units or 4 spaces. Generally, if they don't have a unit on there, like inches or centimeters, you could always just say 4 units. In this case, if you just told me 4, that would be acceptable. Everybody good on this slide? Okay. Now remember, anything that we're learning right now in these beginning days of the school year, everything in geometry builds. Nothing goes away. So when I just taught you how to find the distance between 2 points on a number line, I could ask you that question again come chapter 10. So just remember that nothing goes away, especially like when we start drawing triangles or rectangles. And maybe I'm going to ask you to graph 4 points in a coordinate plane. And then you could just count the spaces if those sides of, say, that rectangle are vertical or horizontal. So this is where maybe this same technique might come later on when instead of just talking about line segments, we start talking about triangles or rectangles, things like that. All right, let's go ahead and define what construction is. So again, I'm not going to ask you to bring a compass or a straight edge or a protractor. All I want you to know is if you ever hear that they're asking you to do a geometric construction, what they would expect you to do is pull out some tools like a compass or a straight edge or a protractor and then precisely draw the figure. Again, you will not have to do that in this class because again, on an SAT or a PSAT, you're not going to be bringing these tools to that test. So that's why I'm not going to require it for this course. My goal is to hit on the topics that you're going to see on those standardized tests. Pretty good on the definition of a construction. Right, let's go on. We're now going to define the word congruent. So congruent is sort of, for geometry, it's like saying that 2 things are equal. But here we're talking about 2 objects. And more precisely right now in this lesson, we're going to be talking about congruent line segments. So when I talk about 2 objects that are congruent, they're going to have exactly the same size and shape. The symbol for congruent is going to be an equal sign with this little wave looking thing on top. That is the symbol for congruent. So right now we're only talking about congruent line segments, but later on I might give you a statement and say this triangle is congruent to this triangle. And what that would tell me is both of those blue triangles that I drew would have exactly the same shape and size. So let me go ahead and draw 2 congruent line segments. And I'm going to show you little things to look for so you can tell if they are congruent or not. So for example, if I draw a segment here and I label it as AB, and then I draw another one below it, and I label that as CD, you can tell that these are congruent by they might show you how long the segment is. They might have a number here. If they have the exact same number, then as soon as you see that they are both the same length, then you know that these segments are congruent. Another way that you're going to see and be able to identify congruent figures or segments is they're going to have congruency marks. And they look like little dashes. So like, for example, if I wanted to state that AB is congruent to CD without giving you a number or a measurement for it, I could just put a little dash. These are called tick marks or congruency marks. So they may not have labeled how long it was, but they might put some congruency marks. Or if they even just give you the statement that AB is congruent to CD. Yes?
What does the 4 mean?
Just that it has a length of 4. I just picked a random number. So as soon as you see that they both have the same length, the same numbers on it, then you know that they're the same size. This statement is read as AB is congruent to CD. That's how you would read that statement. So again, the little red dashes here, these are called congruency marks or tick marks. Postulate number 2, and again, don't memorize that the segment addition postulate is postulate number 2. We just need to know what the segment addition postulate does. Now, in our beginning, when we start to do proofs, we will be using the segment addition postulate as a reason. Now, when we do our proofs, we'll be having to justify why we do something. So sometimes we look for little shortcuts. So I like to abbreviate the segment addition postulate. I like to take the first letter of each one of these words. And I also refer to the segment addition postulate as SAP. So I take the S from segment, the A from addition, and the P from postulate. And if you ever hear me talk about SAP, I'm referring to the segment addition postulate. And what that segment addition postulate states is that if B is between A and C, then that tells me that AB plus BC equals AC. Now, this statement here that B is between, it doesn't mean that B is right smack dab in the middle. It just means that B is somewhere in between those 2 points. And then you could also say the reverse of that. If you're told that AB plus BC equals AC, then you know that B is in between A and C. So let me give you a little visual here. I'm going to draw a number line, or not a number line, a segment, and I'm going to label it with points A and C, and I'm going to put B somewhere in between. I'm going to put it about here. So it's somewhere in between on that segment between points A and C. And now I'm going to go ahead and add some lengths on here, and then we're going to learn how to figure out how big the entire segment is if I know how long each individual piece is. So from A to B, this is going to be a length of 2. And then from B to C, I'm going to tell you that this one, from this little piece here, is a length of 6. I want to figure out how long the entire segment is, and I can use my segment addition postulate. So what I could state is that little piece AB plus BC is going to give me the length of the whole segment. So if I know that AB is 2 and BC is 6, then I know the length of my whole segment is 2 plus 6, and it's going to be 8. So AC is going to be 8. And this is how I can apply the segment addition postulate. Now I'm also going to work backwards, where I'm going to give you the length of the whole thing, and then I'm going to expect you to find a little piece. So let me draw another segment here. Let me draw another one from A to C. I'm going to put B in between. And I'm going to state that from A to B, it's going to be 1. And then I'm going to give you the length of the whole thing. I'm going to tell you it's 5. I want you to find out how much is from B to C. I could call that X. So again, I could use my segment addition. So I know that AB plus BC is going to equal AC. And here's where my algebra skills are going to come in. So if AB is 1 and BC is going to be my variable, and then AC equals 5, I can use my subtraction property of equality by subtracting the 1 and get X equals 4. So my X, which represented BC, is going to be 4. So if they give you the whole thing and one of the little pieces, then we're going to subtract to find the other little missing piece. So this is how I can use my segment addition postulate to find missing pieces of a segment or the entire length if I know the individual pieces. Slide. All right. Wait, okay. Or if you'd rather just take like a screenshot of this one and then you could put this graph into your homework, you can do that as well. However you want to get your graphs into your homework assignment, you can even Google it and look for photos, images for coordinate planes. But some of the homework questions are going to ask you to graph. Now let me just review graphing ordered pairs with you. Remember the first number is the x coordinate and the second number is the y coordinate. When you graph ordered pairs, the first number tells you how you move side to side, left or right, and then the second number will tell you how to move up or down. So I'm going to go ahead and graph J and K in red because it wants me to connect those points to see if it's congruent to segment LM. So I'm going to graph J and K. First, I'm going to graph J. So when I go to graph J, notice the first number is -3. So I'm going to go over to the left to -3 and then up to the +4. So this is point J. And then I'm also going to graph point K. And K is 2, 4. So I'm going to go over to the right to 2 and then up to 4. I'm going to connect. And now I need to figure out how long JK is because I need to see if it's going to be congruent to LM. So I can do two things here. Because I'm graphing it, I'm just going to count the spaces. So if you notice, there's 1, 2, 3, 4, 5 boxes. So JK has a length of 5. I'm going to do the same thing for LM. I'm going to graph L and then M. I'm going to do this segment in blue. So for L, I'm going to go over to +1 and then up to +3. For M, over to the right to 1, but down to -2. Connect those 2 points. I'm going to count the boxes as well. And this one is also has a length of 5. So because JK has 5 units and so does LM, I could state that JK is congruent to LM. You can either write, because it's a segment, the capital letters with the bar or without. Another way that you can do this is use that rule where you find the difference and then absolute value it. So if you've got a visual like this, it's a lot easier just to count those little squares, as long as your graph is accurate. So, for example, the other way that I could do this is I could take my coordinates for J and for K. The part of the ordered pair that is the same, get rid of it, and now I can just subtract. I'm going to do big minus small, so 2 minus -3. And I get keep, change, flip, 2 plus 3, and the length of JK is 5. So I can either, if I don't have a graph where I can count the little squares, I could also subtract the coordinates. If I do LM, L is 1, 3, M is 1, -2. Get rid of the part of the ordered pair that's the same. And now I can subtract. 3 minus -2 turns into 3 plus 2, which again also gives me 5. So again, you can put the bars around it. Again, as long as you're absolute valuing it, the order that you subtract doesn't matter. Okay, but if you do big minus small, it'll automatically give you a positive answer. So you will have to do this on the quiz. You will have to graph 4 ordered pairs and then state if these 2 segments are congruent. You'll have to do it in tonight's homework as well. Yeah. The reason why I get rid of the part of the order pair that's the same, once you're coming up in lesson 1-3 in tomorrow's lesson, we're going to officially learn the distance formula, and you're going to learn that you're going to be subtracting the y's and the x's, and when I do 1 minus 1, like for example on the LM, it gives me 0. And we're going to see that coming up. Okay? Just showing you a shortcut. Here comes our full sometimes, always, or never questions. So you're going to fill in the blank with one of these 3 words. So the length of a segment is sometimes, always, or never negative. It will never be negative because distance is never negative. So the length of a segment will never be a negative number. Number 2, if point S is between R and V, then S, sometimes, always, or never, lies on RV. Let me give myself a visual. So here's my R and V, and if S is between, then S lies on RV, and this will be always. And then the last one, a coordinate can sometimes, always, or never be paired with a point on a number line.
Always?
Always. This is our ruler postulate. So this is how we know this. All right, one more example. Bringing back Algebra 1 skills. Last example says J is between I and K. Yes?
Oh,
What?
I was going to answer.
Oh, okay. Let me just go through it, and I'm going to draw pictures. You already did all 3 parts?
Yes.
Okay. All right. Give me a minute here. All right. Let me go ahead and draw for you. So I'm going to draw a segment, and I'm going to label I and J and K on my segment. So it says J is between. So I'm going to put it about right here. Doesn't matter where. And it states that IJ is equal to 2x. So I'm going to put 2x here. And then it says that JK is equal to 4x minus 6. And then it states that the whole thing is equal, IK equals 30. So in this example, I am going to be using my Algebra 1 skills and the segment addition postulate. Now, when I did this before on the other slide, they just had numbers, not expressions. So it was super easy. So here's how we're going to do it. We're going to show our segment addition. We're going to show that IJ plus JK is going to equal IK. And I'm going to replace. IJ is 2x. JK is 4x minus 6. And then IK is 30. I'm going to want to see this on the quiz, how you're setting up this algebraic equation and how you're going to solve. So now I'm going to use my Algebra 1 skills. I'm going to add my like terms. 2x plus 4x is 6x. I'm going to drop down the rest of the problem. I'm going to now add 6. I'm going to subtract or add, and then I'm going to divide. 36 divided by 6 is 6. So that's the answer to part A. Now to find part B, I know that IJ was given to me as a 2x. Now that I found the value of x, I will substitute and multiply, and IJ equals 12. I'm going to do the same thing for JK. 4x minus 6, replace x with 6. Follow order of operations, multiply, subtract, and JK equals 18. Now, remember, once you get these answers, you can double check yourself, because remember, IJ is right here, so if this is 12 and this is 18, if you go back and add them together, 12 plus 18 should equal 30, and it does.